This is a video from section 3.4. We're looking at the chain rule. If g is differentiable at x and f is differentiable at g of x, then the composite function capital F, which is equal to f composed with g, defined by capital F of x is equal to f of g of x, is differentiable at x, and f prime is given by f prime of x, and by that I mean capital F prime of x is equal to f prime of g of x times g prime of x. And so I think of this as the derivative of the outside function evaluated at the inside function multiplied by the derivative of the inside function. So I always want to be aware of what my inside function is and then what my outside function is. And with that, let's look at some examples. The directions say to find the derivative of the function. And we're going to start with 25. 25, we get y equals e to the tangent theta. And remember here, I have an inside function and then I have an outside function. Now, my inside function we'll say is g of theta is equal to tangent theta. My outside function is f of theta is equal to e to the theta. But remember, if f of theta is e to the theta, the derivative of the outside function, right, f prime of theta, is also e to the theta. And so if I want the derivative of y with respect to theta, I'm going to get the derivative of the outside function evaluated at the inside function. So in other words, I'm going to replace theta with tangent theta. So I'm going to get e to the tangent theta, and then I'm going to take that result and multiply by the derivative of the inside function, which in this case, I want the derivative of tangent theta. Well, that's going to be secant squared theta. Okay? And that's how you find the derivative of y equals e to the tangent theta applying the chain rule. Let's take a look at another example. Suppose I take a look at 30. So on 30, we have f of z is e to the z over z minus 1. Okay? Now, let's take a look at the inside function. And the outside function. The inside function is g of z is equal to z over z minus 1. The outside function I'll call h of z is equal to e to the z. Okay? And so I want f prime of z. Now, I'm going to take the derivative of the outside function, but I'm going to evaluate it at the inside function. So in other words, I'm going to look at h prime of z and then replace z with z over z minus 1. So we're going to get e to the z over z minus 1. And we're going to take that result and multiply by the derivative of the inside function. So I'm going to do this because the derivative of z over z minus 1 is a little bit more difficult. Okay? And so to take the derivative of z over z minus 1, we have to utilize the quotient rule. So we're going to get e to the z over z minus 1 times. Now, I'm going to write down the bottom function, which is z minus 1, and I'm going to take the derivative of the top function, which is, in this case, 1. And this is everything with respect to z. I'm going to subtract z, and then I'm going to multiply by the derivative of the bottom function, which is 1. And I'm going to divide by z minus 1 raised to the second. Okay? And so, therefore, f prime of z is, I'm going to get e to the z over z minus 1 and I'm going to multiply by negative 1 over z minus 1 to the second. Because if we come back, notice how the z's cancel, right? And you're just left with negative 1 in the numerator. And so, again, this says f prime of z is negative e to the z over z minus 1 divided by z minus 1 to the second. And that's how we do problem number 30. If we take a look at problem 33, suppose f of t is equal to e to the t sine of 2t. Okay? So when you get a little bit more comfortable with the chain rule, this is how I would be going through this. So if I want f prime of t, okay, the outside function is e to the t. And so I'm going to take the derivative of e to the t, I'm going to get e to the t. So we're going to take e to the t sine of 2t, okay? So it's the derivative of the outside function evaluated at the inside function, but remember that the inside function is t sine of 2t, which you can let be g of t. But I'm going to multiply by the derivative of t sine of 2t, just like this. Now, to take the derivative of t sine of 2t, we have to apply the product rule. So we get e to the t sine of 2t, okay, times. Now, I'm going to write down the first function, which is t, and I'm going to take the derivative of sine of 2t with respect to t. So let's write that down. So we're taking the derivative of sine of 2t with respect to t, and then I'm going to add sine of 2t times the derivative of t with respect to t. And so this is e to the t sine of 2t. And I'm going to multiply that result by, now I'm going to get t times. Now, the outside function is the sine function. And remember that the derivative of sine is cosine. So I'm going to write down cosine of 2t. But don't forget, you have to multiply by the derivative of the inside function. The inside function is 2t. So I'm going to multiply by 2. And then I'm going to add sine of 2t multiplied by the derivative of t with respect to t, which is 1. And so, therefore, f prime of t is e to the t sine of 2t times the quantity, and I'm going to get 2t cosine of 2t plus sine of 2t. And that's how we do problem 33. Let's take a look at problem number 37. Suppose f of x is equal to sine x times cosine of 1 minus x squared. And I want to take the derivative. So this is a classic product rule problem. So I'm going to write down the first function, and I'm going to multiply by the derivative of cosine of 1 minus x squared with respect to x. And then I'm going to add cosine of 1 minus x squared times the derivative of sine x with respect to x. And so this is sine x times the derivative of the cosine function is the negative sine function. So you're taking the derivative of the outside function, but you're going to evaluate at the inside function. So this is an application of the chain rule. So I'm going to put 1 minus x squared inside these parentheses. And so I'm going to take that result and I'm going to multiply by the derivative of the inside function. So I'm multiplying by the derivative of 1 minus x squared with respect to x. And then I'm going to add cosine of 1 minus x squared times the derivative of sine x with respect to x, which is equal to cosine of x. And so this is, well, this is negative sine x times sine of 1 minus x squared times the derivative of 1 minus x squared with respect to x is negative 2x. And then I'm going to add cosine x times cosine of 1 minus x squared. So I hope you don't mind, I just swap places. And so remember, a negative times a negative is a positive. So what this tells me is f prime of x is equal to 2x times sine x times sine of 1 minus x squared plus cosine x times cosine of 1 minus x squared. And that's problem number 37. Let's take a look at problem number 39. On 39, we have f of t is tangent of square root of 1 plus t squared. Now, I think about this like peeling an onion, right? So when I want the derivative, right, I got to take the derivative of the outside function. In this case, it's tangent. The derivative of the tangent function is the secant squared function. So I'm going to write secant squared of some stuff, right? The stuff ends up being the inside function, which in this case is the square root of 1 plus t squared. And I'm going to take that result and I'm going to multiply by the derivative of square root of 1 plus t squared. And again, we're differentiating with respect to t. Okay? Now, this is secant squared of the square root of 1 plus t squared times the derivative of 1 plus t squared to the 1/2 with respect to t. And so this is secant squared of the square root of 1 plus t squared times 1/2 of 1 plus t squared to the negative 1/2, right? So I'm applying the chain rule again, and then I'm going to multiply by the derivative of the inside function. So I'm taking the derivative of 1 plus t squared with respect to t. Now, the derivative of 1 plus t squared with respect to t is 2t. So f prime of t is 2t secant squared of the square root of 1 plus t squared, right? And I'm going to divide by 2 times the square root of 1 plus t squared. Or if you guys are more comfortable, you can write it first as 2 times 1 plus t squared to the 1/2. So I have to change the sign of the exponent for moving that factor down into the denominator. But the 2's cancel. And so therefore f prime of t is t secant squared of the square root of 1 plus t squared divided by the square root of 1 plus t squared. And be careful, because the square root of 1 plus t squared in the denominator will not cancel the argument of the secant squared. You cannot cancel those. So be very careful about that question. If we take a look at 41, so on 41 we have sine y equals sine squared of x squared plus 1. Okay. Now I'm going to write this a little bit differently. So I'm going to exaggerate these brackets, but I'm going to put sine of x squared plus 1 raised to the second power. And so in this case, the outside function in this context is, we'll say is f of x equals x squared. So when I take the derivative, I get 2x. So when I want y prime, I'm going to take 2 sine of x squared plus 1. But remember, you're taking the derivative of the inside function, which in this case is sine of x squared plus 1. So you're taking the derivative of sine of x squared plus 1 with respect to x. This is one of those interesting ones, because to take the derivative of sine of x squared plus 1 with respect to x, you have to apply the chain rule again. So this is what I mean about peeling the onion. And so here I get 2 sine of x squared plus 1 times. Now, the outside function, inside function dynamic changed. The outside function here is the sine. So the derivative of the sine function is the cosine function. So I'm going to put cosine of x squared plus 1 and then multiply by the derivative of the inside function, which in this case is x squared plus 1. Now, it depends on what your instructor wants. I'll write the solution this way. So y prime ends up being, now the derivative of x squared plus 1 with respect to x is 2x. 2x times 2 is 4x. So you get 4x sine of x squared plus 1 cosine of x squared plus 1. Now, I'll just add, recall, sine 2 theta, that's the double angle identity for sine, so you get 2 sine theta cosine theta. And so you can rewrite number 41 as y prime is 2x sine of 2x squared plus 2. And that would be a legitimate way to write the derivative. And that was problem number 41. If we take a look at 43, suppose g of x is equal to sine of e to the x over 1 plus e to the x. And I want g prime of x. The derivative of the sine function is the cosine function. So I'm going to write cosine of that inside function, and remember that's e to the x over 1 plus e to the x. And I'm going to take the result and I'm going to multiply by the derivative of that inside function. Okay. Now, to take the derivative of e to the x over 1 plus e to the x with respect to x, we have to apply the chain rule. Not the chain rule, the quotient rule. So g prime of x is cosine of e to the x over 1 plus e to the x times. Now, write down the bottom function, which is 1 plus e to the x, multiplied by the derivative of the top function, which is just e to the x, minus e to the x, times the derivative of the bottom function, which again is just e to the x, and I'm going to take that result and divide by 1 plus e to the x squared. And so g prime of x is cosine, put brackets around that, cosine of e to the x over 1 plus e to the x times e to the x plus e to the 2x minus e to the 2x divided by 1 plus e to the x squared. And so the e to the 2x terms cancel, and we get e to the x cosine of e to the x over 1 plus e to the x divided by 1 plus e to the x to the second power. And that was problem 43. If we take a look at 45, suppose f of t is tangent of secant of cosine of t. and I want f prime of t. So the derivative of the tangent function is secant squared, but don't forget, I'm going to evaluate it at secant of cosine of t. And then I'm going to take that result and I'm going to multiply by the derivative of the inside function, which in this case is secant of cosine of t. And so I'm very systematic when you have a composition like this. And so you get secant squared of secant of cosine of t. And I'm going to multiply by, now remember the derivative of the secant function is secant tangent. And remember that the inside function is cosine t. So I'm going to get secant of cosine t times tangent of cosine t. But remember, you have to take the derivative of the inside function, which in this case is the derivative of cosine t, which is negative sine t. So I'm going to take this result and multiply by negative sine t. And so this is equal to, I'm going to pull the negative sine t out in front. So I get negative sine t times secant of cosine t times tangent of cosine t times secant squared of secant of cosine t. So you just have to be extraordinarily careful when taking the derivative of something like 45. And we'll call it good for this video. This is a video for section 3.4. And we worked problems 25, 30, 33, 37, 39, 41, 43, and 45. Okay, thank you.